This is just piggybacking from yesterday, so it's still the same section. Just the key here is, of course, recognize that you're subtracting, and then you need to distribute the negative sign, right, that subtraction sign, to each term in the following polynomial. So basically you flip the signs of every term inside the second polynomial.
You think adding or subtracting is harder?
I mean, subtracting is harder just because it's an extra step that you have to remember. It's not hard, it's just like one more step. It's like longer. Okay, so here's what I'm saying. Here's an example. 4n squared plus 5 minus negative 2n squared plus 2n minus 4. First thing we notice is that this is subtraction, right? We are taking one polynomial and subtracting another. So what we're going to do is distribute in, basically multiply each of these terms by a negative 1, which all it does is flips the sign of each term. We change this to a positive, we change this to a plus after we distribute, okay? So then it becomes, the first term is the same, 4n squared plus 5 plus, and then we do our distribution. So negative times negative 2n squared gives us a positive 2n squared. Distribute the negative to the second term. Negative times a positive 2n gives us negative 2n. And a negative times a negative 4 gives us a plus positive 4. Okay? Now we're doing addition. And so now we can just basically remove our parentheses and combine like terms like we were doing yesterday. Okay? Start with the n squared terms. 4n squared plus 2n squared is 6n squared. Now it's plus. Once we distribute, it becomes plus. There's only one n term, which is negative 2n, so we just bring that down. Minus 2n. And then we add our constants. 5 plus 4 gives us positive 9. Okay? Malia.
So, I'm confused because it's...
Oops.
Oh, wait, never mind.
Is this in standard form?
That's a good question. Is this in standard form?
Yeah.
Yes, because our biggest exponent is n to the second. So we take that term, and then our next one is our n, and then our last one is our constant. Good. But you do always want to check that. That's a good question. Okay, do this one in your notes. This should be pretty easy. What operation are we doing here? That's always what you want to look for first. Addition. Addition. So we don't really have any extra work to do. We just need to combine like terms. Start with the b terms. 1b plus 4b gives us 5b.
Oh, that's not a 6?
No, it's a b. Sorry. It's a b. Then we have our constants. Negative 10 plus 3 is negative 7. Malia.
I thought when you, combined like terms, you... Oh, wait, that's just... Never mind.
You good? Okay. All right. First thing to notice, because this is going to affect the rest of the problem, is we are subtracting. So we have a subtraction sign in the middle. That means before we can do any combining of like terms, we need to distribute and change this subtraction to a plus. Okay, that's always our first step, is to distribute the negative sign, multiply every term by a negative, or flip its sign, and we change our middle sign to plus. So we get p squared plus p plus 3. Those stay the same. The subtraction becomes addition. And then we distribute. So negative times a negative becomes positive 4p squared. Negative times a negative becomes positive p. Negative times a positive becomes negative 3. And now we just have addition. So we can remove the parentheses and combine like terms. 4p squared plus p squared is 5p squared. And then p plus p is 2p. And 3 minus 3 is 0. So you do not need to write plus 0.
Whoa.
You can just leave that off.
Why did you do the distribution of the negative to the left?
You only do the distribution of the negative to the polynomial that comes after it. Only to what comes after it, because that's what you're subtracting. Okay, copy this one down. Try it in your notes, and then we'll go over it in a minute or two. Okay, how did you do? Check your work up here.
I have a question.
Yes.